In this video we're going to look at how to change the subject of a formula. Here is a formula. It's a formula which relates to the perimeter of a square, and I've decided to label the sides of my square X. You could choose any letter if you like, and the perimeter is going to be labelled P. So just before we get on to changing the subject, we're going to have a look at how this formula produces numbers, pairs of numbers, and what I'm going to do is I'm just going to do a little table of values, just so we can explore what's happening with this formula. And I'm going to choose different squares of size 1, 2, 3 and 4. So you can imagine this first one represents a square like this, 1, 1, 1, 1. Now the perimeter of that square is 1 plus 1 plus 1 plus 1, or 4 times 1. The perimeter of the next square that I'm going to do is a bigger square. 2 plus 2 plus 2 plus 2. That's 2 times 4. You can see this is where the formula comes in. I don't want to draw a square each time. I just want to know that I'm going to be multiplying by 4. So let's try it without drawing a square. 3 is my X number, the size of my square, and I'm multiplying it by 4 to make the perimeter. And the last one, a 4 by 4 square. To get the perimeter, I do 4 times that X number, which is 4 4s, which makes 16. Now, what I really want to know, in order to be able to sort of change the subject of this formula, is if I were to carry on this list, and if I were to ask, okay, what square has got a perimeter of 36, how could I work backwards? How could I find out the size of the square that has a perimeter of 36? I could use a trial and error. I could keep counting up, I could keep drawing these squares until I get to the point where it is, or I could try and be a bit more mathematical about it and work backwards. Let's have a look at a little number machine or flow diagram to explain what I was doing. I was taking the number in the X column and I was multiplying it by 4 to make the number in the P column. If you're going to work backwards, if I'm going to give you a perimeter and ask you to work out what the side of the square was, it seems reasonably intuitive that you would divide that by 4. And that's because multiplying and dividing are opposites, inverse, if you want to use the correct word. So this one, X times 4 makes P. We wrote like this, P equals 4X. And this one here says, if I read it backwards, P divided by 4 equals X. So I could write it like that, but it's more often that we switch those two around and write it like that. So this was my original formula that I was given, and I was using that to work out the numbers in the P column. P was the thing we were working out, and we call that the subject of the formula. So you can identify the subject of a formula because it's the letter on its own on one side of the equals symbol. And in this version, when I was working backwards, remember I said, what happens if I give you a perimeter of 36, can we work out the size of the square? In this version, I've now got X on its own on the left hand side of the equals sign, and so x is the subject. The process of going from the first formula to the second formula is called changing the subject of a formula. There are a couple of ways you can do it. With simple formulas you can use this sort of idea, which is number machines and working backwards. But with more complex formulas you're going to need to use balancing method, similar to that you would use for solving equations. So let's have a look at another equation. Sorry, I should say formula. Here is another formula, m equals 3n minus 2. This one I've just made up. It doesn't refer to a particular situation, but it's certainly something that you might see. And let's just have a quick look at how we can work this one out. Well, first of all, let's just start by getting a little table of values done. If I start with these numbers, again just chosen because they're simple, the formula says if I have an n number, which in this case I'm going to start with 0, I need to multiply it by 3 and then subtract 2. And if I do the same with this, if I put a 1 in that position of that n, I get 3 multiplied by 1 and then subtract 2. If I do the same with 2 and 3 and 4, you can see that I've built up a little table of values. And let's just try to write down what I was doing in a flowchart. I was taking a value of n, I was multiplying it by 3, and then subtracting 2 to make my m number. So how do I work backwards? Well, just reverse the steps like that. And now I've got to try to write this as a formula. Well, let's write down m plus 2. And then this second arrow says that I need to divide the answer that I've got. And this whole thing, this m plus 2, is the answer that I've got. And then divide it by 3. So notice how I put the line representing division all the way across under my m, under my 2, because that's indicating that I had to do the plus 2 part first and then divide the answer by 3. Now I can just switch those two things around just to make it look a bit neater. And I've changed the subject of my formula. N is now the subject. Right, let's have a little look at how you might do that in using a method which might benefit you in future for more difficult formulae. So we'll take the same problem, m equals 3n minus 2, and the question will say something like, make n the subject of the formula. So this method is going to involve balancing, very much like what you would do with equations. Let's have a look at our formula, and let's have a look at a very similar equation that you might see. I'm just going to switch around the order in which these two things appear. So let me just write this like that. And I'm going to switch the order of this, so I'm going to get 3n minus 2 equals m. So I haven't changed anything about the formula, I've just written the equals, the two statements on the other side of the equals. The reason I've done that is because what I'm going to do here is I'm going to use an analogy. I'm going to ask you to think how you would solve this equation and then apply those same techniques to this formula. So hopefully you will know that if you're going to solve this equation here, a good starting point is to add 2 to both sides of the equation. So we get 3n minus 2 plus 2, and if you simplify that you just end up with 3n, and 10 plus 2, if you simplify that, it makes 12. So let's try to apply the same reasoning to this formula over here. Plus 2 to both sides. And what you will end up with, just like you do here, 3n minus 2 plus 2, that is going to make 3n. And this m plus 2, I ask you to simplify that. Lots of people would say, well, it cannot be simplified, and they'd be quite correct. M plus 2 can't be simplified, so you just have to write it as m plus 2. That's the bit people sort of get a little bit confused about. They start to write things like 2m or m2 or try to miss out the plus. So you could just write down what you did, m, and we added 2. Okay, let's go back to this stage here. What would I do now? Well, I think we'd be dividing by 3 to work out what n is on its own. And you get n equals 4 in that case. Let's try applying the same step over here. We definitely get n, because it's the same step as we got here. 3n divided by 3 simplifies to make n. So we have the same thing here, 3n divided by 3 makes n. And here, n plus 2 divided by 3. How do I write that? Well, I have to write down that the whole of m plus 2 is divided by 3. So I have to use the longer division symbol to show that the m plus 2 happened first. That was the first step I took, and then I divided it by 3. And you'll notice that this now is our answer. N is the subject. So we have completed the question. And you don't have to write this out, this is just so that you can see that it's the same process as solving an equation, but this is what you would want to write out, and this is the answer you'd be looking for. Let's just check it's the same as we had before. Up here, yes it is, m plus 2 divided by 3. Now, in this question, we're asked to make p the subject. Again, I'm going to do it 2 ways, using the sort of number machine method and then the balancing method. But I am going to have to switch to the balancing method entirely for some questions coming up in a minute. So let's go with the number machine method. I'm not going to do a table of values. I'm just going to ask us to look at this p and try to work out what we have to do to it in order to make the value of t. So we have to start with our p number. First thing to do is divide by 4, and the second thing to do is to add 2. Now, if we want to reverse that process, we're going to need to first of all subtract 2 and then multiply by 4. And if I want to write that out, that says t subtract 2, and then I need to multiply the entire answer by 4. I need to show somehow that I did the minus 2 bit first before timesing by 4. And the way we do that, use your order of operations. How can we show that this minus 2 came first? We can put it in brackets. it's very important that you do put that in brackets. Otherwise, if you wrote this, you would be indicating the incorrect order. You would be indicating that we times by 4 first and then subtract 2 as we're working towards our value of p. That's not correct. It must be the correct order. Minus 2 first and then multiplied by 4. So that one's incorrect. That one is correct. Let's have a look at how balancing can help us out here. So there are a couple of ways that you could do this. I'm going to start by subtracting 2. And remember, we just have to simplify each side of the equals sign. So let's have a look at this bit here first. T subtract 2. Can you simplify that? Nope. So we just write it down. P over 4 plus 2 minus 2. Can you simplify that? Yes, we'll just have the P over 4. Now, because I've got a divide by 4, and remember I want to make P the subject, so I want P to be on its own, I'm going to multiply by 4. P divided by 4 times 4 gives you P, and here again, at this point it has to be made really clearly. We've subtracted 2 already, we've already done that step. Now we've got to indicate that we're multiplying that answer by 4. So we have our T minus 2, and then multiplying the entire thing by 4. So you get your brackets, and that's the correct answer. And remember, it's nice to write it with the subject on the left hand side. That would be your answer. Okay, this time just to show you what happens when you've got a division, a sort of long line division in your formula to begin with. You could do this as a number machine, so you could say r plus 1 divided by 5 equals a. So working backwards, you could get a times 5, which is 5a, minus 1 equals r, and get your answer like that. That seems quite quick and simple in this case, and you may prefer to use that method for simple examples. It's not going to work on the next one that I show you then. So if you really want to be able to do this well, you're going to have to try to get to grips with balancing, and in this case I'm multiplying by 5 to begin with. I can't subtract 1 here, because if I subtract 1 from this bit, that's really worth 1/5, because it's been divided by 5. So I'd have to subtract 1/5 from here. It's a bit of a sort of wrong move, I suppose. You could do it, but people make mistakes on that all the time. So the best thing to do is multiply by 5, and that will get rid of that divide by 5. Then what we're going to do is take away the 1. 5a minus 1 equals r, and if we switch it around like that, same answer, both methods. Right, now here is one where trying to use a number machine method or a flow diagram method won't work. So we're going to have to balance this one. The question says make L the subject. So what do we have to do? Well, start with your formula and look and see if you can identify the term that L is in. There it is. Okay, so we're going to want to isolate 2L to begin with. In other words, get rid of that 2W. And then once we've got 2L equals 2 something, we're going to divide it by 2 so we can get L equals something. So keep this where it is for the moment, and what we need to do is get rid of this 2W. Well, because it's added on, the best way to get rid of it is just going to be just take it away, just like you would with a normal number. And people do get a bit scared at this point. It's worthwhile just thinking perhaps of the W as, I don't know, 10. Okay, so if this was 20, what would you do? You'd take away 20. Since it's 2W, just take away 2W. Again, P minus 2W cannot be simplified, so you have to write it down. And this bit, plus 2W minus 2W, will just make 2L. Okay, there it is. Just that block, just that term containing L. And then the last step on this one, divide by 2, because we want L to be the subject all on its own. And we end up with that formula. And again, I would say it's just nice and neat to write it down like that. So I'm going to do a couple more examples where you cannot use a flow diagram. And generally speaking, you can't use a flow diagram if there are 3 letters in the formula, because things will get just too complicated. So let's have a look at this formula and let's try to make X the subject. So start off by writing out your formula, and this time my X is sort of in this area here, XY, and it's been divided by 5. So I'm going to start off by timesing by 5, because I know that that's going to cancel out that divide by 5. So just check what I've done there. V times 5 makes 5V, that's correct. And XY divided by 5, but then times by 5 again, just makes XY. And now I've got this X times Y, X multiplied by Y. If I want to get X on its own, I'm going to need to do a division. And I'm going to need to divide by Y. Imagine that that was a 5, so it said X times 5. You'd divide by 5, wouldn't you? Okay, if it was X times 4, you'd divide by 4. So try and think of the letter as a number, work out what you would do with it to get rid of it, and then turn it back into a letter. Okay, and once again I'm just going to switch that around to make it neat, and I've made X the subject. Done. Okay. This one is a familiar formula if you've worked out the area of a trapezium. In GCSEs you get this formula given to you, which is quite nice. It's the formula of a trapezium, and it says add together the parallel sides, multiply by the height, and then half it. Or you can do some of those things in slightly different orders if you like. Drawing a flow diagram for that would be incredibly difficult. You'd have to say, well, I'm adding A plus B, so I've got 2 inputs, and then I'm multiplying by H, so that's a 3rd input, and then I've got to divide by 2 or times by half. It's very complicated. So what you need to do here is your balancing. Let's make A, little a, the subject. Okay, so I'm going to make it B. Let's make B the subject just so that when I'm talking about it it's not confusing. We're going to write out the formula like that, and now there are loads of steps you could take here. Some people would prefer to multiply out the brackets to see what they've got. Some people would prefer to divide by h to begin with, but I see this fraction here, this 1/2, and I think I don't like halves, so I'm going to multiply both sides by 2, because I've got a half of something, and then I double it. Guess what? I don't have a half of it anymore, I've just got the whole thing. So half of a plus bh, just think of that as one thing, one number, half of it, times it by 2, I get it, the whole thing. And a times 2 is 2a. Now at this point, I'm thinking, right, I want to get access to this bit, because this is where my b is. This is the sort of little bit of algebra with a little expression with b in it, but it's been multiplied by h. So I'm going to divide by h to remove it from the right hand side. And I could put brackets in there around the a plus b, but there's no point now because I'm not multiplying it by anything. And now I just want to get b on its own, remember, there it is. Okay, so I need to get rid of this a, so I'm going to subtract it away. You get b equals 2a over h minus a. Let's write that out a bit nicer here. And we're done. Okay, here are 2 questions for you to have a go at. If you pause the video now, and then I will go over the answers. Right, number 1 can be done in 2 ways. You could do a number machine, and then reverse it. So you get y times 5 plus 4 equals x. Okay, that would be correct. Or if you did it the balancing way, you'd times by 5 both sides, and then add 4. And you can see it's the same answer. Okay, this question here can't be done using a number machine very easily. I mean, I suppose you might be able to do it. Better to try to use balancing here. So we're going to take away b, and then we're going to divide by a, so your answer should have been m minus b over a.